So starting with the first question, when to use a hash set and when to use a tree set in Java. So we know that both of them belong to the Java collections framework. So the main intent of asking this question is you should be able to understand there are different like multiple set implementations. As we can see over here, we have hash set, we have sorted set, and then sorted set is being again implemented by tree set, enum set, okay, linked hash set. So the intent of asking these kind of questions is that are you able to understand when to use which set implementation. So when you are asked these kind of questions, be very clear and specific. Hash set is used when you do not want any duplicate elements in your collection and you also do not care about the order of the elements. So that is the reason why now you are getting constant time performance because the underlying data structure is your hash table. So anyway, I've covered everything about the internal working of hash set in a dedicated video as part of the Java Core Java interview checklist, as part of the Core Java interview questions playlist. So you can check that out. But the point is hash set underlying implementation is a hash table. And if you have a good hash function, it will provide you almost constant time performance. So no duplicates, unique elements, and no order is being maintained. This is the USP of a hash set. So when you have to tell that what is the use of a hash set is this, two things: unique elements, like no duplicate elements, constant time performance, and third thing is there is no order. There is no order maintained. And one more thing is hash set can allow at least one, like it can allow one null key. But coming to tree set, what is the advantage of using a tree set over a hash set is the order wala point. In case you want to store the element in a certain order, ascending order, descending order, then you should be using a tree set. Why? Because if you provide a comparator along with the tree set, you will be able to define the order in which you want to store the elements. So that is the USP of using a tree set. Also, another thing which you can talk about is the operations which you do. They are not having constant time performance like we had in hash set. It is having logarithmic like O of log n time complexity because we are using a tree data structure, underlying data structure. So we talked about the comparison of the underlying data structure. We also talked about that one is maintaining order, another is not maintaining order. But the common point is both of them will be storing unique elements. So if you see this particular, so when do you want to use tree set? You want to store, let's say, a set of unique usernames, but in alphabetical order. So if you see this particular code example, we have a comparator in which we are comparing the length. So now if I have a set of strings in which I'm going to store certain strings, but when I want to create a set of it and I just want to use it, I want in the set, in that particular collection, I want the ordering of the elements to be maintained on the basis of the length. So first, like the kiwi should come, which has length 4, then apple, banana, and then strawberry. If you had not used a length comparator over here, the elements would have been sorted in their natural order, like the lexicographical or alphabetical order. But if you want to override their behavior, that is the reason why we use comparators also. So if you use that and this logic is for length comparison, then instead of sorting it alphabetically or lexicographically, it is going to sort it on the basis of the length of the strings that you are provided. So this is how, just a small glimpse of how you should be using a tree set, and hash set is something which we generally use a lot of times by default. Now the follow-up question is, tree set is not thread safe. So if they'll ask you that it is not thread safe, so can you tell me that what will you use instead of that? So the answer to this should be concurrent skip list set. So concurrent skip list set is it what it does is it also implements the sorted set. So the mechanism of having sorted elements also you are getting, the mechanism of having unique elements also you are getting. So ordering is done, the duplicate thing is also taken care of. The third thing which comes into the picture is the concurrency or the thread safety. So now that to take care of the thread safety, you cannot use a hash set, you cannot use a tree set. So then you should be using concurrent skip list set. So this is how you should be countering the answers, like the questions, whatever is being asked. Okay, moving on to the next question. Do you know about the 12-factor methodology to build a microservice? Now, do not expect the exact question to be like this. Why I've written this thing is because I want to explain all the 12-factor methodology, like the entire 12. Like I want to explain all the 12 factors which you should take care when you're building a microservice. Very importantly, now it is very much possible you will not be asked all the 12 factors, or maybe whatever you can remember out of the 12 factor, you'll be able to answer that if they ask, or maybe they'll just pick one or two factor, or maybe they'll just pick one or two factor and tell you to expand or elaborate about that principle. What is that principle, for example? So these are the possibilities which you can expect from this. So you have to know, in this world of microservice, when you're building, you have to know about all the 12 factors. So the first is about code base, that you should be having one microservice, one code base. Simple. One microservice and one code base. Different versions of the service can be deployed from this. So you should do this so that there is no duplication of code. Okay. And if there are any common libraries, you should make a different repository for that. Second is about dependencies, that you should explicitly declare and isolate the dependencies. So declare all the dependencies using dependency management tools like we use Maven in case of Java, right? So each microservice should be self-contained. Your microservice should have the dependencies bundled. That is what we even do. Maven, Gradle, NPM, whatever language you're using on the basis of that. This is a very generic methodology. Don't think it is only for Java. Microservice development, when it comes, they have to take care of these 12 factors. Code base is done, dependencies is done. Third thing is about the configurations. So anything which is, environment variable kind of a thing, which we usually store as environment variables, right? So which can change. The database URL can be different for your staging and your prod. The keys, the username, password, all of these things are going to change per environment. So those things you should never store inside hard coded. Of course, you should not store, and that you should not be storing in your application.properties also in case of Java Spring Boot. Rather, use environment variables to manage the configuration based on what environment it is in. And it should be easily managed from outside the code base. It should not be hardbound, tightly linked with your code. The next thing is treat backing services as attached resources. So your databases, anything that you are adding in on top of your microservice to do some business logic, some interactions which you are doing, those should be as attached resources, which means today if you are using MySQL, it is possible that tomorrow you want to move to Amazon DynamoDB. Just because you're switching the database doesn't mean that you have to entirely change everything in your code base. Little bit of modification is still okay, but it should be more like detachable resources, just like a plug and play. So that thing you have to take care of. That is the reason why we also study about design patterns, right? That in the interface we should have generic methods, so that if we change the implementation, we do not have to change our entire implementation or the concrete classes. The next point is about build, release, and run. So you should have strictly you should have separate stages where first your code will be built. Okay, then your code will get released, like deployed in production or into staging, and then it will run. So you should build the code into an executable artifact. Okay, combine it with the configuration, create a release, and run the release. Simple. Like the CI/CD pipeline. This is the entire core of the CI/CD pipeline, right? That you should first build it, Maven clean install. Okay, apply the configuration on top of it, let it pull from wherever your configs are stored. You'll create a release, and that release will be deployed into the environment wherever you're deploying. A simple CI/CD pipeline will take care of this. So this is why we need a CI/CD pipeline, is because we want to take care of the separate build and run stages. Now the next point is execute the app as one or more stateless processes. So what is state? In cloud native microservices architecture, state is some information. That information which is persisting between request or transaction. So your microservice should not be storing any such information in the memory. Always try to store it maybe in some DB or some distributed cache, so that let's say your process, your application crashes, you would not lose anything. You would not lose any data. Everything will still be consistent. So that is the reason. And of course, when you do that, it will be very easier for you to scale up or scale down your instances. So that is the reason they're saying that microservice should be stateless. It should be independent and self-contained, like not having any state information stored anywhere else other than maintaining it outside. That is in external services. So then if you do that, automatically you can scale horizontally. And also it is very much fault tolerant and resilient also when you do that, right? So that is why you should always keep this in mind. Do not store anything in the memory. Always introduce some layer of caching in between if you really want to have some kind of, a low latency kind of thing, or maybe anything which is business logic heavy, persistent data which you want to store. Use a DB, store it over there, so that let's say your app also crashes, you will not be losing anything. Next point is about port binding. So we know that in case of Spring Boot, right, that the HTTP request, we listen it over 8080. So every microservice should expose the functionality by binding to a port, so that it also gives you a separation of concern. Your dev port, your staging port, your production port, everything should be on separate ports, so that they can listen to that specific port and be accessible via HTTP or whatever protocol. Next point, 8 number point, is scale out via the process model. This is very similar to what we discussed, that you should be having separate processes for different workloads. So this is very similar to this, that every process should be stateless, self-contained and stateless, and should be handling a specific task, and we can scale it independently. So that thing you have to take care of. And if you have different workloads, then you should be having different instances or applications for the same. Disposability. So what does disposability means? When you will allow your app to gracefully shut down, or your app to be, efficiently or robustly start it up whenever you require it. So the startup and the shutdown should again be, in a very self-contained and a graceful manner, so that again you do not have to worry about whenever you have to scale up or scale down. You do not have to worry about your app crashing or shutting down unexpectedly. And the startup time should also be very minimal. And to have the startup time minimal and to have a graceful shutdown, only we have all of these 12 factors taken care of, like your configuration being sorted and being self-contained, your dependencies, and then, using some caching in between. So all of this together, all the factors together help you to build a good microservice. So you have to maximize the robustness. We call our app is robust and resilient, that it will bounce back very nicely, quickly, if they can handle the termination and clean up the resources. We call those kind of apps really robust and resilient. The next point is dev prod parity. So you should keep your dev, staging, prod. Parity means similarity. So it should be similar to, like, they should be really alike to each other. You should not be like staging will have a lot of dummy and a fake data, which can be easily manipulated. And prod, and also your staging data should not be like you just have 100 or 200 data sets only. If your prod deals with millions of data, in the staging also you should be simulating that millions of data. If not, like, if not more, but at least you should have similar kind of data volume in your staging also, for example. So that you should be able to avoid any kind of surprises because you have already tested on similar data volume. That is one aspect of it. Another aspect is to use the configs, dependencies, and everything similar. That your, like, the dependencies which you use in your properties, everything should also be having the same thing. Nothing should be hard coded also in your staging, right? So the same CI/CD pipeline which you're using in prod, you should also be using a CI/CD pipeline in staging, so that you can simulate. Staging is more like a simulation, right? So you should be able to simulate the flow of what is happening in production in your staging also. Logs. Next point is logs. To treat logs as event streams, like a stream of time ordered events, so that the logs can be aggregated and analyzed in a centralized location. The reason why we use Elastic, ELK stack with Spring Boot, and also maybe Splunk in some cases also we use it. I think in my previous company I've used Splunk a lot. So anyway, so the reason for doing that is, So the reason for doing that is when you have logs being aggregated in a centralized location, it is easier for you to debug, troubleshoot in case of any issue happens. So for monitoring and analysis, it's really useful. Finally, admin processes. Any kind of one-time activity, one-off activity which you want to do, that should be run uh, only once, like as a starting. Let's say some script you run at the beginning, and that should be done. For example, you just want to download some dependency from somewhere. Just one example. Use a script to do that just before your application is started. Do not do it within the microservice. So that is again giving you a separation of concern. So these are the 12 factors which I explained you, like, just to give you an entire overview. Now questions might come from here. So you have to know about this. Okay, so next question is, how do you prevent circular dependency in Spring? Circular or cyclic dependency as we know it. So the question can be either you'll be asked how to prevent it, or you'll be asked what is cyclic dependency, why does it happen, and then a follow-up question can be how to prevent it. So you have to understand that this happens firstly. Why? Because when two beans or more beans are dependent on each other directly or indirectly. So in the sense, if I say it is dependent directly, then the very simple example is class A has auto-wired class B, and B has auto-wired C. And if it is a circular, like if you have indirect beans, so A is dependent on B, and then C is dependent on B, and again A is dependent on C, something like this. So this is the circular or the cyclic dependency, which can happen when there are two or more beans. So direct dependency or circular indirect dependency, the problem is same. The compiler, like the Spring, it is not able to understand which component it has to create first, which class or which object it has to create first. And because of this, you get this exception, being currently in creation exception, and your server will not start. So this is the reason why it happens, and this is a background. Now, what can you do to break this? So remember this, if you have newly written the code, like you've just created some class, some interface, abstract classes, you've just nicely implemented some code, a very fresh code, the first thing which you should do is you should try to refactor your code and just see that, is there any way can we break the dependency between the classes, probably by using some design pattern. It may happen that you have not written it correctly, and probably that class should be put in some, let's say in a util class, and you have created a bean of that unnecessarily. Like there can be n number of examples that you may need to refactor the code. So first you should be doing is, you should try to refactor the code if possible, using a better design technique. If it is not a new code, if it is not a fresh code that you have written, and if it is a legacy code in which this is happening, then a couple of things you can do. one more thing you have to understand is why this occurs, this cyclic dependency occurs mostly whenever we use constructor injection, because we know that constructor injection is something which we use for the mandatory dependencies what we need in our class, right? So because the constructor is trying to create the objects, during that time only in the while it is building, it is going to fail because it is not able to find the beans that it needs. So constructor injection is one key point. So maybe instead of constructor injection, you would want to use, let's say, field level injection, where you just do add the rate auto add on top of whatever class you need, that you can do a setter injection that you can do. Or the third way can be to use this lazy annotation. So in lazy annotation, what happens is I'll tell Spring to initialize the bean only when it is first needed. So for in this case, let's say if I had used lazy over here, so I can give you this example also in case of class A and B. I'm saying class B is lazy, and for class B also I've used lazy. So when I will need A, during my runtime, when I will need A only, then I'll create the object of class A. And during runtime, when I will need class B, in case of this context, then only I'll create the object of class B, or the bean of class B. So you can use this @lazy also. This will help to break the cycle by delaying the creation. And the next thing which I said is you can use field level auto vary or setter level auto vary, whatever the case may be, instead of using constructor injection. So all of this you should do when you have refactored your code and you see there is no more scope of change, or if it is a legacy code in which you have to fix some issue. So this is the thing in which you should be answering this question. Okay, so our next question is where would you use parallel stream and sequential stream? So this is, of course, as you can understand, this is in the context of Java 8, where we have lambdas and streams being introduced. We have this stream method, and we have another method called parallel stream, right? So now where would you use each of them can be a potential question, because you will say everywhere I'll use stream, and or maybe to increase my throughput, everywhere I'll use parallel stream. It doesn't work really right. There are certain things which you have to keep in mind. So first of all, a normal stream, where we use it when we want to process the element as it goes, as it comes, right? So we'll process the element one by one in a single thread. So each element we process it in whatever order it comes, and we just process and we are done with it. And it happens in the single thread, so it is happening sequentially. Like here we have a list of names. One by one, I'm just checking. First I'll check John, then I'll check Jane, then I'll check Jack. It is not like I'll check John and then I'll go to Alice and then I'll go up to Jane. It doesn't work like that. Okay. And then this is with the, now in case of parallel stream, the data is split into multiple different chunks, and there are multiple threads who process them concurrently. So that is the main logic behind using parallel stream, because that is the reason why the throughput gets increased, performance is better, and you are taking advantage of multiple CPU cores, because now you have broken your data, like let's say you have 10 names and two names are being taken by each thread. So 5 threads are in action, for example. And this is how you use it, names.parallel stream. But the question is, where would you use which one? So when should you use a parallel stream? Always should we use it just to increase the throughput? No. If you have a large data set, and also if you have a large data set, you want to split the workload. If your tasks are very much CPU resource intensive, like you have to do some mathematical calculation, where I can utilize the CPU cores, that is second thing. When you do not care about the order, like in whatever order your message has come, you do not want that to be processed in that particular order, then you can use. And if your stream operations do not have any blocking calls, because that's a trade-off. If you have any IO operation or something, then it will again come back to the same thing. Then parallel stream will not be able to optimize it well, because it's saying that it will negate the performance benefits. Anyway, the threads will have to wait. So these are the things which you have to understand, that you shouldn't really be, using normal stream. Then in these cases, you can use a parallel stream. But when not to use a parallel stream is just the opposite. Smaller data sets where your performance, so now if you have smaller data set, why would you want to engage so many threads in it? Order is very much important. And like CPU bound task, parallel stream, IO bound task, better to use normal stream. And most importantly, thread safety, right? If the operations in the stream are not thread safe, okay, using a parallel stream can lead to race conditions. I've already talked about at length in my Java threads concurrency playlist about all this race condition, thread safety and everything. You can check that out. The playlist link is in the description below. So always keep that in mind. Randomly do not use parallel stream, and that is what you have to also answer in your interview, that you should be understanding what are the reasons of using each of them. That is the purpose of this question, right? Next question is when to use @bean and when to use @component in Spring Boot. So you have to understand the major differences. @component we are using at the class level, and that will automatically get detected by the Spring's component scanning. So we write in the the base packages in which the component scan has to happen. And it is used for the Spring managed classes. Like you want those beans to be managed, those objects to be managed by Spring. You do not want any additional configuration for that. So for that, services, the classes, service class, repo class, all of that controller, you want those to be managed by Spring, and that's why you define @component on the top of the class. But @bean is very specific. First, it is used on a method level. It has to be used inside the @configuration class, and this is going to give you more control over how the beans are getting created, because you are explicitly specifying the definition, the configuration. Like you want specific set of things to happen, some configuration to happen, and most famously, like we use it for data source configuration, right? So @bean we will use to create third-party libraries, like some third party, some like, for example, even database is a third party library, right? Or maybe using some vault connection. So those external resources, if you want to configure it by setting their specific properties, then you should be using that. This is how it should be. You will have a configuration class and @bean. That's it. So component, @component is used for standard Spring managed components, where you want those classes to be automatically detected while doing the class path, component path scanning. And @bean you should be doing when you want more control over how the bean should get created. That's it. Very simple. Okay, next question is, walk us through the steps you would take to mitigate the slow DB queries for a high traffic Spring Boot app. So it's a very real-time kind of a scenario-based question, that if your DB queries are running really slow, what are the steps you can take to mitigate this? Okay. So first of all, we need to identify the queries which are running. So you can do this simply by setting this property to do the show SQL, which will show you what queries are getting logged. And you have to understand from the logs what are the long running queries. And next thing is, okay, so only this part is about, you have to identify first, because before even solving or simulating something, you have to understand what are the, let's say, top 5 queries which are taking really long time, because you want to drill down on that level on which queries are actually taking long and why. And to find out only, we can do these things, that we can examine the logs, which is taking more time, see the logs, see the queries, and use some monitoring tools like this, which will which will analyze your query's performance also, if you cannot figure it out from the logs. So this is done, that we have understood these are the queries. Let's say we have top 5 queries now. Now you have to understand how this queries ran. So firstly, you can use this command explain or explain analyze to understand how it will execute the query. So it will be something like, for example, you have a certain query, select star from whatever. Before that, just write explain. So why this is important is, if your query is using some index, what is the underlying index it is using, or maybe how it is trying to do a join with another table. All of that details you will get to know what is happening behind the scenes. So it will look for full table scans, missing indexes, inefficient joins, and all of that. Next is to optimize the queries. So see, whenever you have where clause related queries, or you're using order by or join, you must create indexes on those columns on which you're doing these operations. So you can see if the indexes are created correctly in that. And you should be doing a bit of query refactoring if you are seeing that maybe, let's say, you're using too many subqueries. Okay, you can try to break it down. The next thing which you can do is the schema optimization. So now see, all of this we are suggesting ways, right? Not necessarily all of them you need to do, but you have to know all the 100 ways to do it, so that you can pick which top 10 ways you want to pick, right? So one is to examine this, how the query was executed. You can see, check for the indexes. You can check if the query can be rewritten in any way. Then you can see if the schema can be optimized. And many a times we just write the code without even checking taking a look at the table schema, right? So if the schema is actually having enough information, or is it again overloaded with information, redundant information. So in that case, you may want to split the tables or de-normalize it, which will, if it is a select query, like any read query, and read query is getting slower, which means definitely something to do with the data getting overwhelmed in tables, right? This is about your query database schema level optimizations. Next is from the code level, you have to see what are the things you can do. So one is batch processing, right? So there is a thing that, for example, you are trying to fetch, let's say you want to apply a certain operation to all the rows in your table. So are you going to apply that all together? I mean, let's say you're trying to do it in chunks of 25 rows, or you're going to do it one by one. So batching or chunking logic is done so that not every row is getting affected one after another. You can just batch all the operations, okay, together and put it in some list and then do the operations against that. So that is one thing which you can do to reduce the number of DB round trips. We call this round trip. Or you can also use lazy loading, but batch processing is also efficient. Next is to use some caching. Again and again, if you're hitting too many times, if you're hitting the DB, for that you will have to cache the expensive queries result, so that again you do not have to overwhelm the DB every time. Next is you can do pagination, right? If you do pagination, then you know that you are not again overwhelming the DB. You're just hitting, like limiting the amount to how much data you needed and only returning that, not overwhelming the DB. Database wise configuration. So, okay, let me just revise. What are the things we have found? What are the queries? We have tried to see on the query level optimization if we can do any. We have seen what is the application code level optimization if we can do any. Now we are seeing on the database, our database level, like connection pool. So I've already covered this connection pool thing when I talked about the tips to improve Spring Boot performance. So connection pooling you should be using so that all the connections are happening not one by one, but they're pooled together, and you can adjust these pool size, and that is the place where you'll be needing your @mean. Database tuning. So again, this is very much dependent on your company wise. I cannot say what it will be, but these are the things that you have to know a very surface level. Also, if you know it, then you can tune it accordingly to your business. And this is done. Then what else can you do? So far, if you have reached, I think by this time you will have solid data to optimize your DB queries. Now, DB queries can be of two types. It can be either the read performance is bad or the write performance, or maybe even both are bad. So how do you know if you have actually fixed it? So before again deploying for the second time, you should be doing some load testing this time. So JMeter is very popular, where you can try to simulate it using multiple high number of threads and identify if you're getting any performance bottlenecks again. Because instead of simulating it and pushing it and again testing in production is not a good idea. And once you see your load testing has passed, you can just do continuous monitoring like New Relic or Datadog or Splunk, whatever you may be using, even ELK, whatever you may be using. So you have to monitor how your queries are performance, how the queries are performing, right? So here's a summary of what are the things we have done. First, identify the slow queries, analyze on the query level, optimize on the code level if you can do something, batching, caching, pagination, batching, caching, pagination. Then on a database and connection pool level, load test it, and then deploy it, and then keep on monitoring after you deploy. Simple 6 steps, just have to remember this. That's it. So the next question is, when would you use a monolith over microservices? We all know the microservices benefits and everything, but we have to understand that certain cases we should be using monolith, right? So the question is more towards understanding whether you know when to use microservices or you're using microservices left, right, and center. Okay. So here are the points which you have to come up with. If your team is just starting up, right? If you're a solopreneur or something, you're just starting up, just simply starting up a very small project, your POC or side project, you would not want microservices architecture. So small, straightforward applications where you do not want the overhead of managing multiple services, deploying it, and all of that, you want to keep it as a monolith, simple monolith. So next problem is the latency. So wherever you need your low latency is like very, very critical. You do not want to add extra latency or delay in the service calls by using microservices. There will be overhead of network calls. So a monolithic approach is going to be really, really important and crucial in that point. Resource constraint. So like I said, I give the example of starting up and solopreneur. You may not be having multiple teams. And one thing is like when you have microservices, it gives you have seen this point that you have this liberty of creating different services in different programming language. And of course, if you have a small team or you are working solo, why would you want that? So that completely makes no sense to have different microservices working in completely different world, right? So if your team is small, lacks expertise to manage the complexities, then again, a simple monolith is what you should be going for. Deployment simplicity, same as what we have just discussed. It's easier to scale up or down a single service, which is in a single code base, and you do not want the CI/CD of multiple services to be done. Next is about consistency, because you know that distributed applications become way too verbose and complex when you have multiple services, right, running. And if that is a concern for you, you want the consistency to be very strong and all the components getting updated all together at once, then you should be using Monolith. So again, performance optimization, it is going in hand with this latencies point, that if you have really strict performance optimizations, right, and it is highly optimized for a set of tasks, monolithic architecture will be offering you, sometimes surprisingly, it will offer you better performance than being integrated into a microservice architecture. So maybe if you're not able to remember all the 6 points, but you get the broader perspective of, one is performance constraint, one is team sizing, one is deployment simplicity, right? Then just 2 to 3 points, if you remember, you'll be able to expand on that. And this is the thing which you should always remember whenever you're making a choice as to where to use a monolithic, or should I split up into different microservices. Not just to appear as a cool techie that you're using microservices everywhere, left, right, and center. The next question is, why do we need an embedded server in Spring Boot? We have found get default embedded server in Spring, right? Why do we need that? So one by one, let's see. When we embed the server, it simplifies the deployment process because we do not have to manually install a separate web server and do the configuration. We are free of that. So just let's say you want to Dockerize it, you just have to install the Java and run it. So you do not have that web server configuration while you're trying to deploy. So it's a very one click, one touch deployment. In microservices architecture, when you're using numerous microservices, right, if you're using an embedded server like we are having in Spring Boot, each microservice is very much independent and self-contained. So because of that, again, your development and your entire CI/CD becomes very seamless, right? Next is third is it fits well with modern. So I just said modern containerization, because when you're containerizing it using Docker, let's say, everything is bundled and your Docker file is comparatively really very small. It's not a pain to do a deployment. Not a pain to do the deployment, and not a pain to maintain and monitor it in environments like Kubernetes. Next point is, the application with embedded server can be executed in any environment, yeah, wherever Java is installed, where you do not have to install a heavy duty web server on your own. So increases portability, consistency, blah blah. Embedded server images are smaller, right? So your jar size is going to be significantly smaller because of that, compared to traditional server setup. So it creates lightweight container images. So your container images are not going to be very heavy. So boiling down to the same thing, faster deployment. So just write your code and you're done. So these are the points which you should remember. The gist, the main crux of the thing is, it is going to help you in simpler development and simpler deployment. That's it. That's the main reason why you should be using an embedded server. So the next question is, do you know about distributed tracing and why do we need to use it? Okay, so this is with reference to your logs, that whenever we use our logs, which are directed in, I mean, there are multiple logs in different microservices and you want to debug some issue has occurred. Now if there was no distributed tracing in place, you would have got lost as to backtrack that, okay, this log is coming as part of which request, right? So normal logs are often isolated as individual services lack the context. So to use why we are using distributed tracing, the reason is to get a unified view, because we are able to backlink the logs from multiple services. And because we are able to link it and trace it, that is why we call it distributed tracing, because it is happening across different, hopping from one service to another, right? So one user has interacted with multiple services, so it will help you to follow the journey of that request across. So from you placed an order, then it went to payment, then it went to shipping and all of that. So it is hopping from one request to another. So to get a complete flow or the life cycle of that request across the services, you would use it. So what is a trace? So there are two terms which are important, trace and span. Trace is the entire life cycle. That request ID which came, what is the entire life cycle? So this is the trace. And span is a single unit of work within a trace. So these are like different spans. So it can be for one single service. So within trace, you can have multiple different span IDs. Span 1, span 2, and so on. And trace ID is what is going to link all the spans together. So when let's say you're using any APM, maybe ELK, right? So you can just search by the trace ID, and you'll understand what are the different span IDs, and maybe search in your log accordingly what happened to that request. So what are the key concepts which you have to understand? Now, again, I am also talking as an interview question, and I'm also trying to explain it to you what it is. So you'll be asked about what we were asked, what is distributed taste tracing and why do we need to use it? Why do we need to use it is very simple, because it is providing us a unified view, because we will hop from one service to another. You can give an example. And what are the key concepts? You have to know what is trace, trace ID, span ID. So trace, like I said, the entire journey of the life cycle. Span is the small unit of work, what is done in that particular time frame. It will have a start time, end time, and all of that. And the corresponding unique identifiers are the trace ID and the span ID. Spans can have parent-child indication relation. So one span can trigger another span. So that can also happen, right? These are the things which you have to use, understand. And how do we add this? We use Spring Cloud Sleuth's starter library, which will, if we add that in our form, we will be able to get the trace and the span IDs. It will get automatically propagated, and you can view that. And you can also structure your log4j XML to format it accordingly, how you would want, like with a timestamp or something. Okay, so that is the gist of it. You have to understand what it is. Then whatever questions are short, whatever questions are directed to you, you can understand and answer it accordingly.